Welcome back to the Top T Testosterone Fundamentals course. In this video, we're going to go over the two testosterone signaling pathways. So this describes the two main pathways that testosterone takes to signal for different functions in the body once it's produced and circulating in your blood. Once testosterone is produced and released into the blood, about 44 to 65% of that circulating plasma T, meaning the T in your blood, is bound by sex hormone binding globulin or SHBG, and 33 to 54% to albumin. I know we discussed this already in the module about the HPG axis production pathway, but I'm just mentioning this again just so you guys are fresh with the information because it's relevant here. So that leaves approximately 1 to 3% available as free testosterone. This testosterone is free to leave the capillaries and signal for different effects in the body. So let's talk about the two main signaling pathways. The first and the main one is the genomic pathway. Free testosterone can bind to the androgen receptor. Throughout basically all of biology, molecules bind to their respective receptors to signal for different processes and mechanisms to take place. Androgens like testosterone bind to androgen receptors, while estrogens like estradiol bind to estrogen receptors, and dopamine binds to dopamine receptors, etc., etc. Once testosterone binds to the androgen receptor, it influences gene expression and DNA and signals for many different functions to take place. For example, it activates mTOR muscle protein synthesis, it lowers myostatin by boosting follistatin, it boosts IGF-1 receptors, it increases strength via the conversion to DHT, it increases fat loss by boosting adrenaline receptors on fat cells, and by transforming pre-fat stem cells into soon-to-be muscle cells. It increases bone density and signals the bone marrow to produce red blood cells. Those are just a few things that testosterone does through the genomic pathway. Now, the non-genomic pathway is somewhat newly discovered. Traditionally, it was thought that the genomic pathway was the main way that most hormones are used, and now this non-genomic pathway is gaining more traction and gaining more awareness in the scientific community, and we have a pretty clear understanding of how it works to some degree at this point. And there are lots of studies on this, all of them are cited in the citations. Free testosterone is also capable of signaling different effects in the body without having to bind to the androgen receptor. The effects of this non-genomic pathway are mainly nervous system related, but there are a handful of others, including calcium regulation, meaning regulating calcium, making sure it's going into your bones and out of your tissues and your blood vessels. The effects of androgens through this non-genomic pathway yield effects like increased strength, increased energy, improved cognitive function, increased confidence, increased risk-taking, decreased fear, decreased anxiety, decreased depression, decreased hesitation, increased desire to increase social status, and increased sex drive. Now, the mechanism behind the non-genomic pathway is free testosterone actually binds to different receptors for other molecules. That's it for this module, guys. In the next one, we're going to talk about what you can do to actually increase your testosterone. This is the one you've all been waiting for.